12, 2013, standing in for July 14, 2015. This is it, a minute-by-minute simulation of Encounter Day. It's make or break.
Well, it's the most important because we've best been spending the 24 hours of the most intense activities that we've been running on the spacecraft, and this is the longest that we've been out of contact since we've entered encounter rehearsal. This may be a rehearsal, but New Horizons has been firing its thrusters and spinning in space, identical maneuvers to those planned for 2015. On Encounter Day, the spacecraft will be too busy taking data to send back images. That's why its first simple "I'm alive" message will be so important.
Sometime within the next minute, DSS 43 should lock up on the signal.
We're good. We're nominal. Spacecraft's nominal, and it looks like all the observations that we had planned between the last track and this track happened.
So this gives us good confidence that at least the spacecraft has been performing all of those twists and turns that we've been anticipating it to over the last 7 days.
I like to say that at the flyby, I don't want to be learning anything about the ground system or the spacecraft or the team. I want to be learning only about the Pluto system.
No spacecraft has ever been to Pluto, nor will ever go back in our lifetime.
Pluto is every child's favorite planet. You know, you ask anyone under the age of 6, and they're going to say Pluto.
We don't exactly know what Pluto looks like, but it looks very exciting from the images we have from the Hubble Space Telescope so far. We really can't wait to get there and see what it actually looks like. So if anybody says that Pluto is boring or not important, no way.
Before New Horizons arrives at Pluto, most everything we think we know about the planet and its moons is up for grabs.
Virtually every place we've sent a spacecraft on a first reconnaissance mission like this, that we find out that our Earth-based notions were flat wrong. So I'll tell you what we expect, but before anything, what we expect is to be surprised.
From the 1990s through today, Stern has been consistent in avoiding speculation.
You get the same answer everybody's gotten from me for almost 20 years. I don't make predictions, except for one. My best guess is we're going to find something wonderful.
But in the final months leading up to the July 2015 encounter, it's hard for most humans not to imagine what we'll see. Many planetary scientists, like Paul Schenk, base their expectations on what we saw when Voyager 2 reached Neptune, and specifically as it flew by its moon, Triton.
Voyager was a 10-year-long exploration of the outer solar system, and every time they got to a planet, it was basically the first time anybody had really seen those bodies. So when they got to Jupiter, they were greeted with enormous surprises. The erupting volcanoes on Io were just completely unexpected. And so when they got to Uranus, there were more surprises. The exotic trains of Miranda and Ariel, for example, were not expected. So by the time they got to Neptune, they were kind of accustomed to the idea that they were going to be surprised. And sure enough, Triton completely blew them away.
Bonnie Barati was at NASA's Jet Propulsion Lab as the first images of Triton, a moon of nearly 1,700 miles diameter, came down.
Triton was almost a twin of Pluto. It's about the same size, about the same brightness.
Originally, Triton was probably a Kuiper Belt object just like Pluto, floating around in space, but then it got too close to Neptune and it got captured by Neptune's gravitational field.
Recently, Paul Schenk enhanced the original Voyager data to create this detailed flyover of Triton.
It has odd patches and odd blob-like features, kind of like amoebas crawling around on the surface. Triton has very few impact craters. Its surface is extremely young geologically.
And it actually has geysers spurting material off into space.
Here is a body that is hundreds of degrees below zero. It's so cold, it's forlorn, it's barren. We just didn't expect to see this activity on Triton. It was quite a surprise.
If you just assume that Pluto was going to look exactly like Triton, which is the most similar object we know about, then you might expect to find a very interesting body.
But Triton is not the only dynamic ice world in the outer solar system. 16 years later, the Cassini spacecraft sent back images of Saturn's moon, Enceladus, about 300 miles across.
This is a tiny little moon, and Enceladus is actually a winter wonderland. It's very bright, It reflects almost all the radiation that falls on it, and it has these huge ice volcanoes spewing out from its south pole.
And Enceladus is continuously giving off puffs of water vapor, and so if you start to see puffs of water vapor coming off Pluto as New Horizons gets closer, that would be exceedingly interesting.
But what forces can power volcanoes in the deep freeze of the outer solar system?
Triton and Pluto are both balls of ice with presumably rock in the center, and so one of the sources of energy is radioactive decay inside the rock, which gives off heat, just like the Earth is heated. If you just let Pluto sit there and pump the heat out of the rocks, you generate enough energy to melt a couple of 100 kilometers worth of ice. It's still possible to have an ocean beneath a relatively thick ice shell. The ice shell might be 100 miles thick or so. Over billions of years, the ice shell gets thicker and thicker and thicker as Pluto cools, and as it does so, it squeezes the water underneath, and if you squeeze the water too much, then it may well actually create fractures and the water could jet out to the surface.
When you're going out to the edge of the solar system, you kind of have to expect some surprises, and we're going to see them at Pluto as well.
Just as Triton and Enceladus were mere dots before spacecraft reached them, until now, Pluto has been an astronomer's planet. That's about to change.
We are going to start off as astronomers, and we'll be using astronomical tools to try and sharpen up our images and pull every last little bit of detail out of these fuzzy blobs. We gradually turn from astronomers into geologists as we get closer and it becomes a real world.
Jeff Moore was in the room at JPL as those Triton images came down, but he also enjoys field work and thinks we'll recognize some similar planetary processes at work on Pluto as back on Earth.
So I'm a geologist, and although we don't expect to see oceans on Pluto, there are common processes which operate on this planet, which are likely to operate also on Pluto and its moons.
While the scales are very different, erosion shapes landforms here on Earth and all across the solar system.
There are these little finger-like projections that are formed by the process of erosion, where wind and water have sculpted this landscape by taking advantage of small differences in the strength of the original rock, creating large, huge, fantastic landscapes, such as on Jupiter's moon Callisto, and we can anticipate that we may perhaps also see landscapes like this on Pluto and its moons.
Pluto's 248-year orbit is more eccentric than our solar system's terrestrial and gas giant planets, greatly varying its distance to the Sun. But it's typical of many other objects in the Kuiper Belt and newly discovered planets around other stars. That, plus its highly angled polar tilt, combine to produce strong seasonal effects.
In fact, the seasons of Pluto are amongst the most extreme of any seasons on any world that we know of orbiting the Sun.
And those extremes may be one reason why its surface is also extremely contrasty.
Pluto is perhaps the most intensely bright and dark place that we've seen in the solar system. This dark surface collects more heat. It warms up like asphalt does on a sunny day here on the Earth. And if there were frost that had settled on this dark surface, they're being heated up and driven off, and the transportation of this material could also be creating wind. So you might see small dunes oriented along the periphery of the dark surface, showing this process in action.
For planetary scientists, color can be a clue to the composition of surfaces that can't be sampled directly.
On the Earth, these kinds of colors from red to dark gray are generated entirely by the presence or absence of rust. On Pluto, we see also these same ranges of colors from gray to bright white to yellow to red to black, but there it must be due to a completely different process.
At NASA's Ames Research Center near San Francisco, longtime Pluto researcher Dale Cruikshank and postdoc Chris Matarese conduct experiments to see what processes might create the colors we see on Pluto, starting with gases like methane and nitrogen and the extreme low temperatures we know are found there.
In our cold chamber, we can produce a thin film of ice, and then after that expose them to a beam of electrons, which are charged particles, comparable to what comes in to Pluto's surface from space. We find that when we shine ultraviolet light or electrons on simple molecules, before too long the simple molecules are broken apart, and by natural processes they reassemble into more complex chemicals. So far, the colors we make in the lab from irradiating these ices is fairly close to what we see on Pluto. There are tones of yellow, light brown, up through fairly dark red. And if we carry the processing by ultraviolet light to an extreme degree, the material actually turns black. And this is almost the color of pure carbon.
Seeing how radiation transforms simple ices into complex and colorful organic molecules should help interpret the close-up views of Pluto's surface that'll be sent back by New Horizons.
Color translates to the duration of the exposure of these otherwise colorless ices over a year, 10,000 years, 10 million years. That may in turn tell us more about the nature of the exposure of Pluto's surface and even the age of Pluto's surface.
Dale Cruikshank began observing Pluto back in 1976. Now, 39 years later, he's ready for its close-up.
We can say that Pluto is chemically active, chemically dynamic. We don't know yet if it's geologically active and dynamic, but that's what New Horizons is going to tell us. We've been surprised in that way before as we've passed other planetary bodies that we had thought were totally cold, dead, inert worlds, and find that there are geysers, there are ice flows, there are cracks, and all kinds of evidence for geological activity.
I can still remember the first time I saw Pluto in a telescope, and it was just a little dot that you could barely see. It will be amazing that within a period of hours, it will be transformed from this tiny dot that I studied as an astronomer to this huge geologic world that will be able to see volcanoes and faults and ices and mountains and craters. I mean, it'll be truly an amazing experience to see it transformed.
So, from sophisticated lab experiments, from exploring other worlds, and from applying insights from terrestrial processes, what should we expect when we get to Pluto in July 2015?
But the only thing that would surprise me would be if we turned out not to be surprised.
But enjoying the scientific surprises to come means avoiding dangers on the last few million miles to Pluto. That's next.